We are now beginning a new unit, Unit 3. We're learning about linear functions. Our first lesson is 9-1, and it's all about functions. Our essential question is, what is the difference between a function and a non-function? We're going to find out in this lesson. First, let's find out what a function is. A function is a relationship in which each element of x of the domain is paired with exactly one element y of the range. All right, let's find out a little bit more. This picture right here has input, and inputs are known as x's, and when we put them into a function, out comes the output. So what is the function, you ask? Let's find out. But first, let's look at these bullet points. The first one says the domain is also known as the independent variable. So those are basically synonyms. They mean the same in math. And they are represented by the x, which is another name for domain or independent. And another name for x is the input. So you have 4 different names for the same thing in math: domain, independent, x, and input. Now, the x value, or the input, or the independent, or the domain cannot be repeated. Let's talk about the range. The range has different names too. The range can be called the range, or even the dependent variable, and it can be represented by the y, or even the word output. And these ones can be repeated. And that's the difference between the domains and the ranges. And now, if you were in the classroom, you would enter into the classroom as you, and all students in this period came through the door as themselves. Then they would exit as you plus knowledge. So then, what is the function of the classroom? Yes. What is it?
What's the function?
Yeah, what's the function?
Knowledge.
Yes, to gain knowledge. So the function of the classroom is to gain knowledge. And the last bullet point says, can there be more than one of you entering? Absolutely not. You are the only you. Even if you had a twin or a triplet, or you had 8 people that look just like you, you are the only you. So therefore, there is only one x, only one independent, and you are an independent. All right, let's get back down into the lesson here. Parts of a function. Well, the first thing that we see here is function notation. And this right here is a function. Let's look at the pieces of this function. The first big arrow is pointing to the red F on the screen, and that is known as the name. I apologize for my pen dragging little lines everywhere. Try to do my best. The next arrow is pointing directly at the X right there, and that is known as the input. Oops, spelled input wrong. And then this next arrow here is directly pointing at this whole piece over here. And that whole piece is the rule to find the output. The next part, we'll look at equations. And if you look at this equation, it looks very similar to the function notation we just left behind. And the first arrow is pointing at the red y, and that is known as the dependent. And the second arrow is pointing at specifically the x value, and that is known as the independent. And finally, the last box in this section is, do they look familiar? Here's the one we just looked at, y equals 2x plus 1. Here's the first one we looked at, f of x is equal to 2x plus 1. And if you look at these two closely, this one and this one are identical. So if those are identical, that means that these two equal each other. Therefore, y has to be equal to f of x. So f of x is equal to y. They are the same. Those are both outputs. Those are both dependents. They are both ranges and both y's. Finally, the name of the function can be an f, it can be a g, a k, or any other variable. It could be a t, it could be an r, or whatever. Textbooks almost always use the variable f to represent the function of something. But it, like I said, can be a g, a k, or anything else. So those are the parts of a function. Let's go right back up here to the function machine. Remember we said the function of the classroom is to gain knowledge? Well, you, as an individual, as an independent, comes into the classroom, learns something, and then you leave a better student. That's the way it's supposed to work. But it is possible for you to come in the classroom, and the function of the classroom is to teach knowledge to you, to teach math. And it's possible to learn nothing in the classroom and come out exactly as you came in. Or it's possible for you to go into the classroom and learn a lot and come out even better. So let's take a look at how to know what a function is and what a function is not. So in this next table, we have two categories. We have functions and we have not a function. So we're going to look at what these are when we're looking at ordered pairs. Now specifically, we have two sets of ordered pairs up here. We're going to look specifically at the x values. We have a 2, a 0, a -1, and 7. Remember, those are all referred to as independents or x values or inputs or domains. And when we look at those x values, we don't see any repeating ones. And so therefore, we know that that relationship between this set sign and this set sign is a function. Then when we look down at the next one, we look at the x values, -3, 5, 8, and 1. And again, we don't see any repeating x values. So we know it is a function. In contrast, when we look at the next ones, we can see that we have a 1 here, a 1 here, a 1, and a 1. Well, this is a very big problem for our function because when we put 1 in the input, out comes a 4 as the output. Well, when we're using the same function again, we put 1 in again, and now we get a 5. How would that happen with a function? Why would the function change? It doesn't change. So when you go in here, you get a 6. You go in here, you get a 0. It's just not working. Something is wrong with the function. So we say that is not a function. Another example would be 2, a 0, a 2, and a 7. Now they're mostly different except for the 2's. In the 2's, you put it in the function, you get a 4, and then another time it goes in, you put a 2 in, and you get a 6. That's odd. That would be not a function. So those are two examples of ordered pairs that are not functions. Now let's look at vertical tables. On a vertical table, you have the x inputs, the y outputs, or even the dependents. Not dependents. The independents and the dependents, also known as the inputs and the outputs. All right, so let's start here. You can see that we have a 2, a 0, a -1, and a 7. So in this domain bubble, we're going to put them in order from least to greatest, as we learned in Unit 1. So we're going to put -1 at the top, then a 0, 2, and 7. Then we're going to list our domains. That's going to be 0, 4, 5, and 6 in order from least to greatest. So 0, 4, 5, and 6. And now we're going to look at these and say, back from our table, what does -1 belong to? It belongs to 6. So we'll draw an arrow from -1 all the way down to 6. Then we'll go to the next one, 0. Well, 0 belongs to 5. So we'll go from 0 and we'll draw an arrow to 5. And then we'll go to 2, and 2 belongs to 4. So we'll go from 2 and draw an arrow to 4. And then finally 7 belongs to 0. And we'll draw an arrow from here all the way up there. Now you can tell that every domain belongs to exactly one range. And therefore, this table is a function. In contrast, when we look at this table, we'll do this again, but this will list our domains. Remember, we don't repeat domains, so it's 0, 2, and 7. And the ranges are 0, 4, 5, and 6. And you can see that the 0 belongs to the 5 when you put it into the function. So 0 goes down to 5. And then you can see that 2, when you put it in the function, the output is a 4, so you go 2 goes to 4. But the problem is, when you see 2 again, now it goes to 6. So 2 belongs to 2 different ranges or outputs. And that's a problem. We can't put 2 in one time to the function and get a 4, and then put it again and get a 6. It's just not going to work. So this is not a function, because 2 repeats to 2 different values. Take a look at the horizontal tables. The horizontal tables for a function, you can look at the x values, -3, 5, 8, and 1. There's no repeats there. Now the y's are repeating, but that doesn't matter. So this is a function. And in contrast, you can see that the 1s, they're repeating over and over. And in fact, when you put a 1 in, you're getting a 4 out the output. And then you put a 1 back in, you get a 5, and then a 6, and then a 0. You can see that that is not a function. That should not be happening. And the last thing is graphs. For graphs, we use the vertical line test. A vertical line test, you draw your best vertical line you can, and you move it left to right, or right to left. It's like a scanning type bar. So if I blow this graph up here, and I move this line over to the value of 6, and I draw a vertical line right down the x value of 6, you can see that that vertical line test only crosses our line one time. And that moment right there is at 6, -8. So I'm going to write down 6, -8 as an ordered pair. If I travel that vertical line test to the left anywhere I want, and I stop it right here at the value of 2, I can see it crosses one time. And that is at 2, -4. Well, at the value of x being 2, does it cross anywhere else? It doesn't. So if I move this continually back and forth, let's say I move it right here to a value of -3. Well, it's nearly crossing at a value of 3. And it doesn't matter where I move this vertical line test to left or right, it will only ever cross the line one time. So that is a function. That's the vertical line test. In contrast, when we use the vertical line test over here, and we draw it right here, Try that again. I tried to hit 8 as my x value, and it crosses right about here, and let's call that -6. Well, that's fine. It's only crossing at one time. But as I move my vertical line test to the left, and my x value is now 4, I can see it crosses right here at 6. I can see right here it crosses at, that's about 3.5. And I can see that it crosses down here at -5. And you can see that I'm putting in 4, but I'm getting different values. So that is not a function. And if you continue moving this across, you can find other spots on the graph that it crosses twice. And that's another indicator that it's not a function. All right, now that we learned all those things, we're going to go down and practice these. We're going to try to identify which of these things are functions and not a function. All right, let's look at the first one. This is domains and ranges. And if you look carefully, you can see that 3 exactly belongs to -8 one time. But the problem here is 5 belongs to 2 different outputs. So how would that be with a function? It just can't happen. You can't put 5 in and get a 5, and then do it again and get 9. It's just not going to work. So this is not a function. And in the Google form, you'll use all lowercase letters, and you'll write not a function. And you'll have no spaces, all lowercase. And that will give you the right answer. On the next one, it's a graph, and you use the vertical line test. And anywhere you put a vertical line test on this graph, you can say that it's only going to cross that line one time. As you move it to the left, it doesn't matter where you draw it, it's going to pass through one time. If you move it to the right, it doesn't matter, it will pass through one time. And so that means that this is a function. So lowercase letters, and you just write function. Let's look at a set of ordered pairs. Specifically, we need to look at the x values, 2, 7, 3, 5, 6, and -4. There are no repeats, so we know that this is a function. Let's try another set of ordered pairs. -4, 3, -3, 2, 6, and 10. There are no repeating x values. So this is a function. Look at this one. It's a crazy line. Is there a spot where you can draw your vertical line that it would pass through the line at least 2 times or more? Well, there's a spot right here that's crossing the line actually 1, 2, 3, 4, 5 times. So that's definitely not a function. So we write in not a function, all lowercase, no spaces. The next one is a set of ordered pairs, -11, -1, 5, -6, and -4. That's all we have to look at, and there are no repeats, so this one is a function. All lowercase, no spacing. Here we have a set of domains, and we can see that -3 belongs to one thing, -8, -2 belongs to one, -5, 0 belongs to 1, -2, and 4 belongs to 1, -2. And therefore, since we have all different inputs, that is a function. Remember, the y's or the range or the outputs can repeat. And this one's repeating, and that's just fine. The x's cannot. On this next graph, if you use the vertical line test, from left to right all the way across, you can see that's only ever going to cross one time anywhere you go. So this one is a function. This next one, another vertical line test. If you draw the line right here, it's not crossing the line at all. So the only place that's going to be with the line is right on top of it. Well, if it's right on top of it, that means that there are many, many points, actually infinitely many points that it's crossing. So this one is not a function. Here we look at the x values, 6, 6, 6, 6, 6, and 6. If you look at these 6's, this 6 is now comes out as an output as 5, and then you put 6 back in. It should come out to a 5 again, but it doesn't. It comes out to a -7. Therefore, this is not a function. This next line, or it's not a line, but graph, you can put a vertical line test here and it works out just fine. But as we move it back and forth across the graph, we can move it right here and you can see that there are a ton of crossing points. And so this is not a function using the vertical line test. All lowercase, no spacing. The next one, a set of ordered pairs, 2, 5, 3, 4, 6, and 2. Now, it almost seems like it is a function, but this 2 has a 5 as an output, and this 2 has a 6 as an output. So therefore, it is not a function. And again, I apologize for my pen. Working on getting a new one. Here's a table, and if you look at all the inputs, the independents, you can see that we have 32 here and 32 here. That's not a problem if they have the same outputs, but they don't. This one has 23 and this one has 47. Therefore, this is not a function. And now vertical line test again. Draw anywhere along here, you're going to see that it crosses 2 times. And because it crosses twice, it is not a function. Back to a table, take a look at the independents. And you can see that we have -3 and 5/10, -35 and 1/10, -3 and 51/100, and -5 and 31/100. Now they appear at first that there are some repeats, but there's not. And so we don't need to be looking at the independents. Those can repeat. So this one is a function. And the last one's a graph. And anywhere you would draw your vertical line test, it's going to cross through exactly one time. It does not matter where you go. So this one is a function. Now that we know how to identify functions and not functions, let's go down here and finish this off by finding the function values. Now, we talked about it before. The name is right here, g. The function's name is g. And we want to find g of x. So what we have to do is we have to look at what the rule is. The rule is -2x minus 7. So all you have to do is write down the rule, -2 parentheses for the x minus 7. We are using the substitution property. What are we subbing in for x? Well, it says right here, we need to put 2 in for x. So we put a 2 right here. And then we go ahead and use our gems. -2 times 2 is -4. We bring down the -7. You might want to be still using additive inverse. If not, that's okay. This is -11. Now to properly write this in the Google form, you have 3 options. Option number 1, you can do y is equal to negative 11. No spacing. Option number 3 is you write g of x is equal to negative 11. No spacing. That looks super sloppy. This right here, again, is an equal sign, and that's a negative sign. And the third option is writing as an ordered pair. So you always use a parentheses, and our x value in this case is a 2, comma, and our y value is negative 11, end parentheses. No spacing. Those are your 3 options. Most students like using this one because it's least amount of typing. Let's try one more. Let's try another one. We use the same rule. It's the same function. So we write negative 2 parentheses for the x minus 7. This x is negative 2. Whoops. So we put a negative 2 inside. And negative 2 times negative 2 is positive 4. And 4 minus 7 is negative 3. So again, you have 3 options. Y is equal to negative 3, or g of x is equal to negative 3, or even as a point, negative 2, comma, negative 3. Again, I apologize for the pen sloppiness. Pause the video and try the next 3 on your own. Pause now. All right, there's your answers for the last 3. And let's get into your assignment. Always start off with your first name, last name, date, and period, and then read directions before you start. It says determine whether each relation is a function. So numbers 1 through 4, you have to say if it's a function or not a function. We talked about how to answer those in the Google form with no spacing and all lowercase. On the form, it will give more instructions. Number 5. Let's go over this one. So here is our rule. And so we'll write down 3 parentheses minus 1. And inside the parentheses, we're going to put negative 1. And that's that sloppy piece right there. Let me get that fixed. There we go. And 3 times negative 1 is negative 3. And negative 3 minus 1 is negative 4. Remember, you have 3 options to write this in. You could do y is equal to negative 4, or f of x is equal to negative 4, or you could do an ordered pair, negative 1, comma, negative 4. That's how you do those. Then let's take a look at number 9. This one has another rule, and the rule's different now, so negative 6 parentheses. And our first x that we're going to put in there is negative 12. That's a negative times a negative, so that gives us a positive, and the answer is 72. So our answer here can be written as y is equal to 72, or g of x, because the name changed, is equal to 72, or possibly even as an ordered pair, negative 12, comma, 72 for your y value.